Hi everyone, how are you all? So in the last session, we were discussing pigeonhole principle. In the last lecture, we have seen this pigeonhole principle. We have taken some questions, some very good questions we have seen. So this pigeonhole principle, what this says that if you have, if there are k plus one or more pigeons, means if there are more pigeons than pigeonholes, then at least one pigeonhole will contain more than one pigeons. So this is the pigeonhole principle that we have already seen. Means if you have more pigeons than holes, then in this situation, at least two pigeons will go to same hole. They will have to share a pigeonhole. Okay, so this is the pigeonhole principle that we have already seen. Now, in this lecture, we will discuss the generalized pigeonhole principle. Okay, so let's start this. So let's consider this question. In this question, you tell me how many pigeonholes we have and how many pigeons we have. Tell me in this question. See, you can count. So there are total, I think, there are total 11 pigeons. So you can easily notice that there are total 11 pigeons you have. And how many pigeonholes are there? There are total 5 pigeonholes are there. Okay, so you have total 5 pigeonholes. Now you tell me, is it possible that no hole contains more than 2 pigeons? Is it possible? Please tell me, is it possible that no pigeonhole contains more than 2 pigeons? Is it possible? See, can you see that whatever you do, at least 3 pigeons, there will be at least one pigeonhole with more than 2 pigeons. Can you see? Notice what I'm saying. I'm asking, is it possible? This is my question. Okay, is it possible? You have remember, you have total 11 pigeons you have, and you have total 5 pigeonholes you have. Okay, so there are total 5 pigeonholes are there. Now I'm asking, is it possible that no pigeonhole contains more than 3 pigeons or more than 2 pigeons? Is it possible? Is it possible that no hole contains more than 2 pigeons? Is it possible? A simple question I'm asking. First of all, you tell me, before we answer this question, you tell me, if you have more pigeons, here you have more pigeons, right? In this question, you can notice you have more pigeons than pigeonholes. Okay, so this 11, this I can say more pigeons and less number of pigeonholes. So definitely at least one hole will contain more than one pigeon, right? Agree? So this is very simple. This we have already seen that at least one hole will contain more than one pigeons. Okay, so I can say there is some hole, okay, with more than one pigeons. Okay, this will happen. This will definitely happen because you have more pigeons and less number of pigeonholes. So at least one hole will contain, there will be at least one hole which will contain more than one pigeon. So this is very simple. Now my question is, you have 11 pigeons and you have 5 pigeonholes. Is it possible that no hole contains more than 2 pigeons? Please tell me, is it possible? Can you try? Okay, so no hole can contain more than 2 pigeons. So let's try this. Okay, so in this hole, you cannot put more than 2 pigeons. So maximum 2 pigeons here, maximum 2 here, maximum 2 here, maximum 2 here, maximum 2 here. Now tell me, maximum how many pigeons I can put in this situation? Like this, if I do, maximum how many pigeons I can accommodate? So in this situation, maximum 10 pigeons can be accommodated, right? Yes or no? Maximum 10 pigeons can be accommodated, right? Okay, so very simple. This is the very simple point, that if you put maximum 2 here, maximum 2 here, maximum 2, maximum 2, maximum 2 in every pigeonhole, if you put maximum 2, then in this situation one pigeon will be remaining. Okay, definitely one pigeon will be remaining because maximum 10 pigeons I can put. So can I say that is it possible? The answer is no. The answer is no. So what can I say? At least one pigeonhole contains more than 2 pigeons. Can I say? Agree? So what I can say? I can say at least one hole, at least one pigeonhole will contain how many? At least one pigeonhole contains more than 2 pigeons. more than 2 pigeons. Is this point clear? Please tell me, is this point clear? There will be at least one pigeonhole which will contain more than 2 pigeons. There will be at least one pigeonhole, okay, where more than 2 pigeons will go. Okay, is this point clear to everyone? See, very simple. Whatever you do, for example, maybe what you can do, you can put these two here. Okay, what you can do, maybe you can put whatever you do, at least one pigeonhole will contain more than 2 pigeons, at least one pigeonhole. For example, if I put these two here, and let's assume I put these two here, okay, and what I'm doing, I put these two here, and let's assume that I put these two pigeons I put here. Now still you can easily notice that one pigeon is remaining. Okay, one pigeon is remaining. So whatever you do, at least one pigeonhole will contain more than 2 pigeons. I hope this point is clear. Okay, so very simple point that whatever you do, if you do like this, then one pigeon will be remaining. Okay, so if you do like this, now you can notice at least one hole has more than 2 pigeons. Okay, so now you tell me a simple point. You tell me a simple point that why this number is coming, from where this number is coming. Like for example, okay, let's take this simple question that let's assume you have 20 pigeons. You have 20 pigeons, and let's assume there are total 4 pigeonholes. There are total 4 pigeonholes. Okay, you have 20 pigeons and 4 pigeonholes. In this situation, what you can say? What you can say that at least one hole will contain how many? How many pigeons? Please tell me. See, very simple question I am asking. You have total 4 pigeonholes. There are total 4 pigeonholes. Now, what you can guarantee? That there will be at least one hole with how many pigeons? What you can guarantee? See, very simple point. If you do the uniform distribution, for example, I put for example, I can say, if you do the uniform distribution, let me take in this question, let me take first 22 pigeons. Let me take. Okay, let's start with 22 pigeons. Now you tell me, in this question, if I start with uniform distribution, means what I do, I put 4 pigeons here, 5 pigeons here, 5 pigeons here, 5 pigeons here, 5 pigeons are here. Okay, this is what I can do. Still, how many pigeons are remaining? Still, how many pigeons remaining? There are 2 pigeons who are remaining. Okay, there are 2 pigeons who are remaining. So can I say that at least one hole will contain more than 5 pigeons? Okay, yes or no? I can say that at least one hole. I can say that at least one hole will contain more than 5 pigeons. More than 5 pigeons. Is this point clear? Please tell me. Because you can see, if you don't do this, can you prevent this? How to prevent this? I am saying that at least one hole will contain more than 5 pigeons. So how to prevent this? If you want to prevent this, then every hole should contain maximum 5. Agree? If you want to prevent this, you don't want this to happen. Okay, you want to prevent this, then what you will need to do? In every hole, you need to put maximum 5. In every hole, you will put maximum 5. If you do like this, then maximum how many you can put? Then maximum how many pigeons you can accommodate? Maximum 20 pigeons you can put. If you do like this, then maximum 20 pigeons you can accommodate. Okay, very simple point. If you do like this. So if you want to stop this, very simple point, I'm saying to prevent this. Okay, I am saying that to prevent this. To prevent. If you want to prevent this from happening, then maximum 20 pigeons I can accommodate. But I have 22 pigeons. So definitely what I can say that at least one hole will contain more than 5 pigeons. Now let me tell you why, from where this number is coming. From where this, I can say more than 5. Or I can say the same statement I can say like this. The same statement I can say that greater than equal to 6. I can say greater than equal to 6. There will be at least one pigeonhole which will contain greater than equal to 6 pigeons. Now from where this number is coming? From where this number 6 is coming? Okay, I am saying that from where this 6 number is coming. So let me tell you, this 6 number is coming because you have 22 pigeons and you have 4 holes. What you will get, what number you are getting? If you divide, then you will get something 0.5 point something. So, okay, so you can see that this is like extra pigeons. Okay, right? Yes or no? This is like extra remaining pigeons, I can say. This is something extra, means some extra pigeons are remaining. See, very simple point. What I'm saying 22 pigeons are there and 4 pigeon holes are there. Now, if you uniformly distribute, okay, if you uniformly distribute, then in this situation, you can notice 22 divided by 4, 5 point something. This extra number indicates that there are some pigeons remaining. This number indicates that some pigeons are remaining. There are some pigeons remaining. Correct? Yes or no? There are some pigeons remaining. If I put maximum 5, then some pigeons are remaining. So remember, this number indicates that if we put maximum 5, if we put maximum 5 in every hole, if we put maximum 5 in every hole, then I can say some pigeons will be remaining. Okay, so tell me what you need to do in that case. If we put maximum 5, then in every hole, then some pigeons will be remaining. So what we will need to do, I can say some hole will contain 6 pigeons. I can simply say that some hole will contain 6 pigeons. There will be at least one hole with the 6 pigeons because some extra pigeons are there. If I put 5 everywhere, in every pigeon hole I'm putting 5, 5, 5, 5, then some pigeons will be remaining. If you put these pigeons also, okay, then in this situation, at least one hole will contain 6 pigeons. Is this point clear? So I can say at least one hole contains how many? You can take the seal value. You can take the seal value. So it's like you can take the seal value. Okay. So you can take seal of 22 divided by 4. You can take this value. So at least one hole will contain these many pigeons. Is this point clear? Please tell me. Okay. We can guarantee that at least one hole will contain more than 5 pigeons, or I can say we can guarantee that at least one hole will contain 6 pigeons, at least one greater than equal to 6 pigeons. Okay, so I can say at least one hole contains greater than equal to these many pigeons. Okay, so again I am telling you, okay, don't worry, we will take many examples. Right now you are thinking that you did not understand. Okay, don't worry, we will take many questions. But again, let's come to our point number 1. This we have seen in the last class also. If the question is asking you to guarantee something, if the question is saying that some event is happening for guarantee, like there is a guarantee that event X will happen, so what you will do to solve this type of question? If the question is asking for guarantee of event X, then what you will do? You will try to prevent event X. This is what you will do. Very simple. Now, this is important. Let's look at the point number 2. This is your generalized pigeonhole principle. Okay. This principle, this is your generalized pigeonhole principle. Let me tell you, read this note. Read this. This is your generalized pigeonhole principle. Generalized pigeonhole principle. What this is saying? This is saying that if you don't want too much in a single room, if you don't want too much in a single room, if you want to prevent too much in a single room, then what is the best way? Then the best way is to uniformly distribute items in all rooms. Do you agree with me? This is a common sense. If you want to stop too much in a single room, then what you will do? For example, let's assume there is a father. Okay, there are parents, and let's assume there are 5 children. There are 5 children. Now, if you don't want to give too much to a single child, okay, let's assume this father had, let's assume that he has total 27 rupees. Total 27 rupees. Okay, these 27 rupees he want to give to these 5 children. Okay, now if you don't want too much to a single person, then what is the best way? Think about it. I don't want to give too much to a single person. Then what is the best way? The best way is uniformly distribute. Yes or no? Do you agree with me? That, so very simple point. This father does not want to give too much to a single child. Okay, he loves all the child equally. He does not want to give too much to a single child. then what is the best way? The best way is that you distribute uniformly. So these are the 5 children, okay? And the best way is to distribute uniformly, just distribute uniformly. So if I distribute this 27 rupees uniformly, then how much I can give? If I distribute this 27 rupees, I want to distribute among 5 people, 5 children. Then if I distribute equally, because I don't want to give too much to a single child, in this situation, if I distribute equally, then what number I will get? If I distribute equally, then what number I am getting? I am getting 5, right? I am getting 5. Okay, I will give 5 to him, 5 to this child, 5 to this child, 5 to this child, 5 to this child. Now still how many rupees are remaining? Now still how many rupees are remaining? So if I do like this, if I do this uniform distribution, then still 2 rupees are remaining. Okay, still you can notice that 2 rupees remaining. These 2 rupees remaining. So now what these parents can do? Now definitely, can I say at least one child will get more than or equal to 6 rupees? Can I say? Because now two rupees are remaining. Okay, so let's assume you give 1 rupee to this person, you give 1 rupee to this person, or maybe these 2 rupees go to this person. Maybe these 2 rupees they go to this person. Maybe. Okay, so this person has 7 rupees. Now can you notice? What is happening here? Can you notice? At least one child has how many? What can I say? I can say at least one child has more than equal to 6 rupees. This is guaranteed. Whatever you do, at least one child will have more than equal to 6 rupees. Agree with me? Whatever you do, for example, you can do this also. You can give 1 rupee to this child. Okay, you can give 1 rupee to this child. But the point is, at least one child will have more than equal to 6 rupees. Please tell me, did you understand? This is very important point. This is your pigeonhole. This is your generalized pigeonhole principle. If you want to prevent too much in a single room, okay, you don't want to give too much to a single box. You don't want to give too much to a single person. Then what is the best way? The best way is to uniformly distribute items in all the people. This is a very obvious rule. In your real life, you use it every time. Many times in the daily life, you will use this type of things. Okay, if there are 5 children, small children, if you give too much to a single child, then other 4 children will cry. Okay, yes or no? So you cannot give too much to a single child. In this situation, what you can do? You can do the uniform distribution. This is the simple point. Okay, very simple. Now you tell me. So, like, let's start with this example. If you have 100 people, and then what can I say? At least how many of them have birthday in the same month? What can I say? See, if I have 100 people, then what can I say? At least how many of them? What you can guarantee? That at least how many? What you can guarantee that at least how many will have birthday in the same month? Will have birthday in same month? Tell me. Let's understand this. Question. So tell me the answer. You have total 100 people. At least how many of them, at least what you can guarantee? I want to ask you what you can guarantee that at least how many of them will have birthday in the same month. So you can notice that these are the months. Okay, total 12 months are there. You can see. Now you tell me. Now I want to ask you, at least how many you can guarantee that at least these many will be in the same month. At least these many people will be in the same month. Is it possible all can have birthday in the same month? Is it possible? Is it possible that all the 100 people have birthday in the same month? Is it possible? All the 100 people, they have birthday in the same month? Yes, it is possible. But is it guaranteed? It is possible. There is a possibility. I agree, there is a possibility. It is possible, but not guaranteed. Okay, you cannot guarantee this. I won't guarantee. I won't guarantee that these many people will definitely have birthday in the same month. Okay, I want the guarantee, means give me the, like, give me minimum number, no problem, but give me guarantee that at least these many people will have birthday in the same month. Can I say at least two people will have birthday in the same month? Can I say at least two people will have birthday in the same month? Can I guarantee that? Can I guarantee that at least two people will have birthday in the same month? Yes, I can guarantee that. Okay, definitely, because you have more people, less number of months, only 12 months are there, and you have 100 people. So definitely I can guarantee that. This I can guarantee, that at least two people will have birthday in the same month. This I can guarantee. But can I guarantee something bigger? Can I guarantee something bigger? For example, can I guarantee that at least five people will have birthday in the same month? Can I guarantee this? Can I guarantee this? This can I guarantee? See, can you prevent this from happening? If you don't want this to happen, then what you will do? If you don't want this to happen, okay, you want to make sure that no month has, I can say, at least five people. Okay, if you want to stop this from happening, I'm saying that you can guarantee. This is what I'm saying, that you can guarantee. Now, you want to stop, you want to prove me wrong. Then what you will have to do? Then every month should have maximum 4. Every month should have maximum 4. So if you do like this, how many people are possible? If you do like this, maximum 48 people are possible only. But you have 100 people. If you do like this, if I do like this, then maximum 48 people are possible. If I put maximum 4 in every month. So, but I have 100 people. So I can guarantee that, yes, I can guarantee that 5 people, at least 5 people will have birthday in the same month. Can I increase this number? How much I can increase this number? This is the simple question I am asking. I am asking, how much can I increase this number? See, very simple point, very simple point. If you want to increase this number, then what you will do? Tell me what you will do. If you want to increase this number maximum, you want to increase this number to maximum, then what you will do? You will do uniform distribution, right? Agree? So maximum, how much can I guarantee? Like, I'm asking maximum, what guarantee can I give? Just tell me, what is the maximum guarantee I can give? I'm asking, what is the maximum guarantee I can give? This maximum guarantee, you tell me. So if you want to guarantee maximum, if you want to find this maximum guarantee, then what you will do? Then this is what you are going to do. That 100 people, you will do the uniform distribution in all the 12 months. These are the 12 months: January, February, and so on, December. What you will do? You will do the uniform distribution. Okay, there are 100 people, 12 months. You will do the uniform distribution. You will find out in every month, how should I put? How much should I put? So 100 divided by 12. What is that value? Tell me. That value is 8 point something. That value is 8 point something. So can I say that in every month I can put 8 people? 8 people, 8 people, 8 people. Now still something is remaining, right? Still, if I put 8, still something is remaining. Still some people are remaining. How many people are remaining? Tell me, how many people are remaining? If I put 8 everywhere, if I put 8, 8, 8, then how many people are remaining? So then there are 4 people remaining. There are 4 people remaining. There are 4 people remaining. Now, you can easily notice that what I'm saying, these 4 people will also go somewhere. So what can I guarantee? Just tell me. Is it possible all the 4 people can go to the same month? See, already 8 people here, 8 people here, 8 people here. Is it possible or for all 4 can go here? Yeah, it is possible. But it is also possible that these 4 people go like this. One person here, one person here, one person here, one person here. So tell me, what is the maximum guarantee I can give? Maximum guarantee I can give is 9. Okay, because definitely these 4 people, already 8 is there. 8 people here, 8 people here, 8 people here. If these 4 people, okay, at least you can see that already 8 is there. One person will go here. One person will go here. So you will get 9. It will become 9. So what I can say, are you getting my point? Are you getting this point, that if you uniformly distribute in every month, if you uniformly distribute then every month will get 8 people. Every month is getting 8 people, but some people are remaining, 4 people are remaining. If you put these 4 people also, then I can say some month has greater than equal to 9 people. So I can say some month, there is some month with greater than equal to 9 people. There is some month with greater than equal to 9 people. Can I say there is some month with exactly 9 people? Is it correct statement? Is this statement correct? There is some month with exactly 9 people. With exactly 9 people. Is this statement correct? No, this statement is not correct. Please understand. This statement is false. Okay, this statement is false. This statement is false. Okay, I hope this point is clear. Why? How can you make this statement false? See, how can you make this statement false? Very easy. Everyone has 8 people. Every month has 8 people. What do? You give these 4 people to this month. So what will happen? This month will have 12 people. There is no month with exactly 9 people. There is no month with exactly 9 people. What you can do? These 4 people you can give to this month. So there is no month with exactly 9 people. Is this point clear? Please tell me, did you understand pigeonhole principle, this generalized pigeonhole principle? Did you understand? Very intuitive. This principle is very intuitive. Just remember one statement. Okay, just remember this. See, this one. Okay, this note. Please read this note again. Then we will solve questions. The best way to prevent too much in a single room, if you want to stop too much in a single room, if you don't want to give too much to a single person, then the best way is uniformly distribute. Okay, this is the best way if you want to prevent too much in a single room. So just uniformly distribute items. This is your generalized pigeonhole principle. Now let's move on. Let's see this example. Consider this one. Very interesting question. What is the minimum number of students required? Okay, what is the minimum number of students required in a discrete mathematics class? To be sure, we want to be sure. Okay, remember, we want to be sure. We want to guarantee, we want to be sure that at least 6 will receive the same grade. At least 6 will receive the same grade, and grades are these: A, B, C, D, E, F. Okay, so these are the grades. Remember, these are the grades: A, B, C, D, E. A, B, C, D, F. These are the grades: A, B, C, D, F. Now you tell me, the question is asking, you want to guarantee that at least 6 goes to some hole has at least 6. Okay, what you want? What I want? Tell me. I want to make sure. I want to make sure that some grade has more than, I can say, at least 6 people. Okay, make sure that some grade has, okay, any grade, some grade has at least 6 people. Okay, this is what you want to guarantee. You want to guarantee that, you want to make sure that some grade has at least 6 people. So tell me, if you want to guarantee this, can I guarantee this with, for example, 10 students? With 10 students, can I guarantee? If I have 10 students, then can I guarantee with the 10 students? With the 10 students, can I guarantee that? Can I make sure that some grade has at least 6 students? No, with the 10 students, I cannot guarantee. There is no guarantee. There is no guarantee with 10 students, because maybe what can happen? Maybe you have, for example, 3 students here, 3 students here, and okay, here 4 students. So there is no guarantee. There is no guarantee with 10 students. But now let's see. So what is the worst thing you, for example, it's like a game. It's like a game. Okay, this is my task. Okay, this is my task. And let's assume that you are some competitor, or maybe you are, you hate me. Okay, you don't want me to complete my task. Okay, this is my task. I want to make sure that some grade has at least 6 people. You want to stop me. So if you want to stop it, then what you will need to do? Just tell me. If you want to stop it, then what you need to do? To prevent this, what you need to do? How to prevent this? Okay, very simple question I'm asking. To prevent, what you need to do? To prevent maximum 5 people in every grade. Yes or no? If you want to prevent this, then what you will do? Then you will put maximum 5 people in every grade. In every grade. Agree? Yes or no? Agree or not? If you want to stop this, okay, because I want to make sure, I want to guarantee. So if you want to prevent this, then maximum 5 people in every grade. If you put maximum 5 people in every grade, then how many people I can say maximum 5 people you are putting. Then how many people maximum you can have? Okay, to prevent, if you want to prevent, remember, if you want to prevent successfully, maximum how many students must be there? Okay, then maximum 25 students must be there. Okay, yes or no? Maximum 25 students can be in class. If you want to prevent successfully. Is this point clear? If you want to prevent successfully, then maximum 25 students can be there in the class. Maximum these many students can be there in the class. Okay. If you add one more student, then this prevention cannot happen. Agree? If you add one more student, this prevention cannot happen. So if you want to successfully prevent, then maximum 25 students can be in the class. With 25 students, you can prevent. Okay, with 25 students, you can easily prevent. Okay, but if I add one more student, so if you have, it's like 25 plus 1, just add one more student. Okay, so because you are doing the uniform distribution, you want to stop at least 6. You want to stop at least 6. Okay, so if you want to stop at least 6, this is the successful prevention, remember. Is this point clear? This is the maximum number for successful prevention. Remember this point. This 25, this is the maximum number of students for successful prevention. Okay, remember, this is the maximum number of students for successful prevention of 6 in same grade. Okay, so but if you add one more, now you cannot prevent. Okay, with these many students, you cannot prevent. Now with these many students, some grade will have more than equal to 6 students. I hope this point is clear. So simple point that if you want to prevent, then everywhere maximum 5 you can put. Maximum 5 you can put. With maximum 5 everywhere, these many students, with these many students you can prevent. But if I add one more student, if I add, then definitely you cannot prevent. Then definitely some grade will have more than or equal to 6 students, at least 6 students. So this is the simple question. Okay, I hope this point is clear. You don't have to apply the formula. There is no need to apply the formula. Just apply the intuition. There is no need to apply the formula. Just apply the logic. This is my strong suggestion to you, that in the pigeonhole principle, remember, in this pigeonhole principle, the best way is to apply the logic. The best way. This is the best way, remember. The best way is to apply logic, is to think logically. Is to think logically. This is the best way. Because some questions we will see in which you can't even find out, you won't be able to find out what are the pigeons, what are the pigeonholes. There will be some questions in which you will not be able to find out what are the pigeons, what are the pigeonholes. So that is the reason I am saying the best way is to think logically. There is no need to apply the formula. You don't need to apply the formula. Just think logically in the pigeonhole principle. The previous question, did you understand? This previous question that we have seen, did you understand that previous question? This one, minimum how many students, to make sure, to guarantee that some grade has at least 6 people. Did you understand this? Logically, did you understand? This logical understanding, this is very important. Okay, now let's move on. So these are the 2 points. One point is, if the question is asking for guarantee of event X, then what you will do? You will try to prevent event X. And the second point is, The best way to prevent too much in a single room, that is uniformly distribute in all the rooms. So uniform distribution, this is the best way to prevent too much in a single room. Okay, and this is the third point. What is the third point? This is the third point. I told you, don't forget to use your common sense and intuition. This will help you. Let me tell you, this will help you. Just apply your logical thinking. So don't forget to use common sense and intuition. Okay, so just apply your logical thinking, nothing else. This logical thinking is very important. So let's move on now. Let's solve some questions. Let's see this question. Tell me. Tell me. Let's see this question. How many cards must be selected from a deck of 52 cards to guarantee that at least 3 cards of the same suit are chosen? Okay, so let's start with the first one. Forget about the second question first. Let's see the first question. Think logically. Okay, solve this question logically. Just think logically. There is no need to apply the formula. So let's see this question. Now we have, in a standard deck, there are 52 cards. You already know this. There are 4 suits. There are 4 suits. One is heart, diamond, spades, club. These are the 4 suits. Every suit has 13 cards. Okay, every suit that has 13 cards. So now you can see how many cards must be selected. How many cards must be selected to guarantee, remember, I want to guarantee that at least 3 cards of the same suit are chosen. Okay. To guarantee that at least 3 cards of the same suit are chosen. In this question, again, remember, what you want to guarantee? What is the event? What is the event? What is the event of event to guarantee? What is the event to guarantee? Tell me. Just think logically. What is the event to guarantee? Which event we want to guarantee? Which event we want to guarantee? This is the event that 3 cards of the same suit. Okay, I can say at least 3 cards, of same suit, Okay, at least 3 cards of the same suit. Okay, is this clear? This is the event that we want to guarantee. This is the event we want to guarantee. So if you want to prevent this, what you need to do? If you want to prevent this, then what you need to do? I want to guarantee that at least 3 cards of the same suit. If you want to prevent this, then what you need to do? Then maximum 2 cards of the same suit. Cards of any suit. Agree? Very simple point. Very simple point. So this is the event I want to guarantee. I want to guarantee that at least 3 cards must be chosen of the same suit. This suit can be any, I don't care. But the point is at least 3 cards of the same suit. If you want to prevent this from happening, then maximum 2 cards of any suit. Okay. For any suit, maximum 2 cards you will select. So if you do this, so let's prevent. Okay, let's prevent. So if you want to prevent, then maximum, how many cards you can choose? To prevent maximum, how many cards I can draw? Maximum, how many cards I can draw? Remember what I'm saying? Okay. To prevent maximum, how many cards I can draw? So what I can do? For every suit, I can take 2 cards, because there are 4 suits. There are total 4 suits. There are 4 suits, like you have heart. Okay. There is, you can see there is heart, and there is diamond, there is spades. Okay. And one more is there. What is that? That is club. Okay. So anyway, let me just write the name. So you have heart, diamond, and spades, and there is club. Okay. So now you tell me. Now you already know that maximum 2 cards you can choose for any suit. So here you can take 2 cards. 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 So maximum, how many cards I can? Maximum 8 cards I can draw. If I draw one more card, then what will happen? If I draw one more card, now what will happen? Tell me. Tell me what will happen now. See, two from here, two from here, two from here, two from here. Uniformly, I'm taking uniform distribution from everywhere. I can take maximum two. Maximum two I can take. If you want to prevent this from happening, so what I can do? I can take maximum two from everywhere. Okay, so if I take maximum two from everywhere, then maximum 8 cards I can take. Maximum 8 cards I can take. But if I add one more card, now what will happen? This one more card, if I take any, like for example, this one more card from spade, this card can be spade. Then in this situation, I have at least 3 cards of spade. Okay, so very simple. In this 8, if I add one more, now what will happen? Now something interesting will happen. Now you can say there will be some suit, there will be at least 3 cards of same suit. Of some suit. I hope this point is clear. So the answer will be what? So how many cards you should guarantee? How many cards you should draw? So I can say at least 9 cards I should draw. Okay, I can say at least 9 cards I should draw. With 9 cards I can guarantee, remember. Is this point clear? With 9 cards I can guarantee. Means if you draw at least 9 cards, then there is a guarantee. Okay, if you draw at least 9 cards, then what will happen? Then there is a guarantee, remember. There is a guarantee that at least 3 cards of same suit will be there. Okay, I hope this point is clear. Let me know. Did you understand this question? Please tell me, did you understand this question? Very simple question. If you draw at least 9 cards, these many cards, if you draw, then there is a guarantee. Okay. With 8 cards, can I guarantee? With 8 cards, can I guarantee? With 8 cards, you cannot guarantee. See, this type of situation can happen. If you have 8 cards, with 8 cards, you cannot guarantee, because this type of situation can happen. You can see there is no suit with at least 3 cards. In this situation, there is no suit with at least 3 cards. Okay. Now let's see this second question. And remember to use your common sense. Don't forget to use your common sense. Okay, let's solve this question. What the question is asking? Let's see. The question is saying that how many cards must be selected to guarantee? Again, I want to guarantee that at least 3 hearts are selected. At least 3 hearts are selected. Okay, so what is the event you want to guarantee? Tell me, what is the event to guarantee? Which event we want to guarantee? Tell me, which event we want to guarantee? We want at least 3 hearts. At least 3 hearts. Okay, so I want to guarantee that at least 3 hearts must be there. Okay, if you want to prevent this from happening, what you will do? If you want to prevent what you need to do? You want to prevent this, then what you need to do? Maximum 2 hearts you can take. Very simple. Maximum 2 hearts you can take. Okay, maximum 2 hearts you choose. Or I can, okay, so very simple. Maximum 2 hearts you can choose. Is this point clear? If I want to guarantee that at least 3 hearts, I want to guarantee that at least 3 hearts I get. So to prevent, what you need to do? To prevent maximum 2 hearts you will choose. Okay, so what I can do, see something interesting. See what I can do very easily. What I can do, this is your heart. This is your spade. This is your club. And this is your diamond. Okay, now you tell me what I can do. I am selecting cards. I am selecting cards from 52 cards. There are 52 cards total. So what I can do? My only target is maximum 2 I can take from here. Do you agree with me? Maximum 2 I can take from here. Maximum 2 I can take from here. Maximum 2. From here, how many can I take? From here, how many can I take? Please tell me. From here, how many can I take? I can take all the 30, no problem. I can take all the 30, no problem. I can take all the 30, no problem. Yes or no? Maximum these many I should take. From here, I can take all the 30, no problem. From here, I can take all the 30, no problem. Here also, I can take all the 30, no problem. So can you notice? At this point of time, I have prevented, right? Like this is the maximum I can do to prevent. Yes or no? This is the maximum I can do to prevent. I have prevented. So you can see total how many? These are like 41 cards. Using 41 cards, I can prevent. Remember, using 41 cards, there is a possibility to prevent. Is this point clear? Using 41 cards, there is a possibility to prevent. Prevent event X. There is a possibility to prevent event X. Let's call it event X. Okay, so you can see, is this clear? With 41 cards, there is a possibility to prevent event X. Is this point clear? Is this clear to everyone? Please tell me. So if you draw 41 cards, there is a possibility that you don't get at least 3 hearts. This is the important point. Is this point clear? Please tell me. If you draw 41 cards, if you draw 41 cards, then there is a possibility you don't get 3 hearts. You don't get at least 3 hearts. But now you tell me, if I add one more, then what will happen? Now you tell me, if I add one more in this 41, if I add one more, now what will happen? Now there is a guarantee you will definitely get at least 3 hearts. Now, for guarantee, what I will get? For guarantee, I will get at least 3 hearts. For guarantee, I will get at least 3 hearts. Please let me know, did you understand this? This is a beautiful question. Actually, let me tell you something interesting. In this question, you cannot even apply the formula. In the previous question, like there are 2 questions. This question actually you can solve using formula. Formula works here. Okay, you can apply the formula. The formula will work here. But let me tell you, here you can't even apply the formula. The formula will not even work here. Here the formula cannot work. This is pure logical. Logically, you have to solve the problem. Okay, formula doesn't work. Remember, in this question, formula doesn't work. Anyway, we will not apply the formula. Formula doesn't work. Anyway, we are not going to apply the formula. Okay, the formula is boring, but we have seen what is the formula. You already know what is the formula. What is the formula? Tell me. What is the formula? The formula is like this. If you have total n pigeons, and total k pigeonholes, if you have total n pigeons and total k pigeonholes, now you tell me, if you uniformly distribute, then one pigeon will have how many? If you uniformly distribute, uniform distribution, if you do the uniform distribution, then one pigeonhole will have how many pigeons? If you do uniform distribution, with uniform distribution, what will happen? In this situation, what will happen? If you do the uniform distribution, then in this situation, I can say n by k. N, there are n pigeons, there are k holes. If you do the uniform distribution, then n by k. These many will go to every hole. If you do the uniform distribution, then these many will go to, this value will be something like, for example, let's assume this value is something, for example, r dot something. Let's assume this value is r dot something. Now you tell me. So what I can say? So if you uniformly distribute, then these many, in every hole, these many pigeons will be there. If you do the uniform distribution, then every hole will have these many. But something is remaining. If you accommodate that also, now what will happen? Okay, something is remaining. See what I'm saying. I'm saying that if you do the uniform distribution in every hole, these many people will go. These many pigeons will go in every hole, but some pigeons will be remaining. If you put them also, if you put these also in the pigeon holes, then what will happen? Then there will be some pigeon hole. Then I can say there will be some pigeon hole with at least r plus 1 pigeons. With at least r plus 1 pigeons. I hope this point is clear. With at least r plus 1 pigeons. And the same thing you can do like this. You can just simply take the floor. You can take the seal value. You just simply take the seal value. You just simply take the seal value. If this seal value is, let's assume, if this seal value is r, if this seal value is r, or for example, maybe if this seal value is, let's assume, this is t, then your answer will be greater than or equal to t. Is this clear? Let me know. Please tell me. Is this point clear? See, very simple. You have total n pigeons and total k pigeon holes. If you do the uniform distribution, I put uniformly. Uniform distribution if I do, then with this uniform distribution, what will happen? I can say, if I do the uniform distribution, then n pigeons, k pigeon holes. If I do the uniform distribution, then every hole will get r pigeons. Okay, every pigeon hole will get total r pigeons, but some pigeons will be remaining. These will be remaining. If you put these remaining pigeons also, then what will happen? There will be some pigeon hole with at least r plus 1 pigeons. Or what you can do, you can simply take the seal value. You can take the seal, this seal you can take. Okay, just take the seal value and you will get your answer that some pigeon hole will contain at least k pigeons. So this is the formula anyway, but you don't have to apply the formula. You just have to apply the logic. Because in this question, that is the reason this question number B is interesting. The formula does not work here. This is pure logic. If you want to solve this question number B, then pure logic you have to apply. The formula doesn't work here. Hopefully all these points are clear. You can see the explanation also. These two questions are taken from Kenneth Rosen. Okay, you can see in the first question, you can apply the formula. You can do the first question. We have done using the logical approach. We applied the logical approach. We were thinking logically, okay. So, but you can apply the formula also, no problem. You can check it out. This explanation you can read. But something interesting, what is that? If you see for part B, you can't even apply the formula. Yes or no? See, read this line. Read this line. You can't even apply the formula. You cannot even apply the formula if you want to solve this question. So that is the reason, again, I am telling you that logical thinking is very important for the pigeonhole principle. Okay, just don't apply the formula, just apply the logical thinking. For the pigeonhole principle, what you need to do? What you need to do? Forget about the formula. Forget about the formula, just apply the logical thinking. Logically you solve the question. Logical thinking. That's it. Very simple. Okay. If you think logically, then question number B was easy. Yes or no? This question number B, this was very easy. If you think logically that I want to prevent this from happening. I don't want 3 hearts. Okay. How can I prevent this from happening? So very simple. Don't take 3 hearts. Maximum 2 hearts you can take. But you can take all the cards from club. You can take all the spades. You can take all the diamond. So very simple. Ultimately, I can say that with 41 cards, you can prevent this from happening. If you draw 41 cards, there is a possibility. There is a possibility that you won't get 3 hearts. There is a possibility. If you draw 41 cards, there is a possibility that you don't get 3 hearts. But if you draw 42, now there is a guarantee that you will get at least 3 hearts. Simple point. Now let's see. So this formula we have already seen. If you have total n pigeons, n object, and you put them into k boxes, then there is at least one box containing n divided by k seal objects. This is the formula. Just in case they ask you some if they ask you some question directly on the, like this statement they give you, okay, they give you this statement and they ask you fill in the blanks, right? Yes or no? This type of question, if they ask you, for example, what will come here? So in this situation, you can just say that answer will be n divided by k seal. And this also you can think logically. Okay, you don't have to, like, for example, you don't have to by heart. You can very easily prove it. Okay, because what you will do? You will do the uniform distribution. If you do the uniform distribution, then every pigeonhole will contain n by k pigeons. Some pigeons will be remaining. So you just take the seal value. So there will be, if you take the seal value, then I can say there will be at least one box containing seal n divided by k, these many objects. Let's see this question. Tell me the answer for this one. Logical thinking is very important. That is the reason I am taking this question. Please tell me the answer here. Which is true? 14 pigeons you have and 4 holes you have. Now you tell me. What you can say? There are more pigeons and there are less number of holes. So can I say at least 2 pigeons will go to the same hole? Yes, of course. Yes or no? Because you have more pigeons, there are more pigeons, there are less number of holes. You can guarantee that at least 2 pigeons will go to the same hole. This first option you can guarantee. At least 2 pigeons will definitely, at least 2. Remember, this is at least 2. At least 2 pigeons will go to the same hole. What about this? At least 3 will go to the same hole? Yes. At least 4 will go to the same hole? Yes. At least 5 will go to the same hole? No. See, very simple. You have total 4 pigeons. Total 4 pigeons you have. And you have total only 14 pigeons are there and only 4 holes are there. Now you can see that. Tell me, if you do the uniform distribution, if I do the uniform distribution of these pigeons within these holes, if I do the uniform distribution, means these are the pigeons and you have 4 holes. If you do the uniform distribution, then every hole will get how many? If you do the uniform distribution, every hole is getting how many? 3 point something. Okay, so every hole is getting, like, I can say 3. Every hole is getting 3. But still something is remaining. But if you put 333, still what will happen? 2 pigeons remaining. Still 2 pigeons will be remaining. Okay, so these many will be remaining. So what I can say? I can say that some hole will definitely contain at least 4 pigeons, because these pigeons also you will put, these also you will put. So if you put these also, then what I can say? Then I can say there will be some hole with at least 4 pigeons. There will be some hole with at least 4 pigeons. Is this point clear? There will be some hole with at least 4 pigeons. Can I say this you can guarantee? Is this a guarantee? Is this a guarantee? Is this a guarantee? See, this is possibility but not guarantee. Please understand. Please understand, this is not a guarantee. This is not a guarantee, because what can happen? For example, maybe one can go here and one can go here. So please understand, this is not a guarantee. Is this point clear? Is this point clear? That some hole will contain greater than equal to 5 pigeons. This is not guaranteed. This is not guaranteed. There is no guarantee. There is no guarantee. Hopefully this point is clear. But there is a guarantee that at least some hole will contain at least 4 pigeons. Agree? This is definitely guaranteed. Agree with me? Because whatever you do, some hole will contain at least 4 pigeons. Whatever you do, there will be at least one hole. Whatever you do, 14 pigeons, you put them in the 4 holes. Whatever you do, some hole will contain at least 4 pigeons. This is guaranteed. This thing is guaranteed. So here in this question, I can say answer will be option A, B, C. Is this point clear? Option D is not. Option D we cannot say. Option D may or may not. Option D may or may not happen. But option A, B, C will definitely happen. Is this point clear? Option A, B, C will definitely happen. But other options may or may not happen. You tell me, can I say there is some hole with exactly 4. Is this clear? Is this correct? If I say there is some pigeon, there is some hole with exactly 4 pigeons. Again, this is wrong. Again, this is wrong. Please understand, again, this is wrong. Because what can happen? Tell me what can happen. It can happen that, for example, these two can go to the same hole. These two, they can go to the same hole. For example, 3, 3, 3, 5. So there is no guarantee. Okay. Is this point clear? So very simple. All these points we have seen. One more question I want to ask. Let's assume you have 13 pigeons. Let's assume you have 13 pigeons and you have 4 holes. Now, can you guarantee some hole will contain exactly 4 pigeons? Exactly 5 pigeons. Exactly 4. Now, can you guarantee that some hole? Now, can you guarantee that some hole has exactly 4 pigeons? Now, can you guarantee? Please tell me. Now, can you guarantee? You have 13 pigeons and you have 4 holes. Now, can you guarantee that some hole has exactly 4 pigeons? Again, you cannot guarantee, because what you can do, in one hole, you can put all of them. Just put all of them in the one hole. Just put all the 13 pigeons you put here. Put all the 13 pigeons here. Who is stopping you? Who is stopping you? Just put everything here. Is this point clear? Just put everything here. Put everything in the first hole. Put everything here. But even if you put everything, even if you do this, then also this statement is correct. See, this is definitely correct. Some hole with at least 4. This you cannot stop. Are you getting now? Please think logically. See, this you cannot stop. Right? Agree with me? This will definitely happen. See, if you put, for example, whatever you do, if you put all the 13 here, or if you do uniform distribution, or if you do whatever you want, but this you can definitely guarantee that some hole will contain these many. This you can definitely guarantee. Is this clear? This is interesting question. That is the reason, again, I'm telling you. Let's assume you have 13 pigeons and you have 4 holes. In this situation, can I say that some hole will have exactly 4 pigeons? Can I say? The answer is no. Because what you can do, you can put all the pigeons in the first hole. You can do this. You can do this. If you do this, then there is no guarantee this will happen. There is no guarantee. But there is a guarantee that this will happen. But there is a guarantee that at least 4 will go to the same hole. Tell me here, if I do this, all the 13 pigeons I put here, then can I say this is happening? Can I say this is happening? I put all the 13 pigeons here. Now, can I say this is happening? Yes, this is happening. Okay, if I put all the 13 pigeons in this hole, then easily you can see this hole has at least 4 pigeons. Okay, let me know answer for this question. Again, you have 14 pigeons and you have 4 holes. Now you tell me, can I say at least 4 pigeons will go to the same hole? At least 4 pigeons will go to the same hole. Yes, this is guaranteed. You cannot stop it. You cannot stop it. Can you stop it? Can you stop this from happening? Can you stop option A from happening? If you stop this option A from happening, then what you will need to do? To prevent option A, what you need to do? To prevent option A. If I want to prevent option A, then what I need to do? Option A is saying at least 4 in the same hole. At least 4 in the same hole. So if I prevent option A, then every hole should have at most 3. At most 3. At most 3. At most 3. Okay. So very simple. If you prevent option A, to prevent option A, you can have maximum 12 pigeons. With maximum 12 pigeons, you can prevent. Okay, maximum 12 pigeons. But you have 14 pigeons. See, if you want to prevent option A, then option A is saying that at least 4 in every hole. At least 4 in some hole. There is some hole, there is at least one hole with at least 4 pigeons. If you want to stop this, then what you need to do in every hole at most 3. This is what you will do to prevent. So if you want to prevent, then this is what you will do. But you can notice, if you want to prevent, then maximum 12 pigeons can be there, but you have 14 pigeons. So we cannot prevent option A. So I can say with 14 pigeons, we can't prevent option A. With 14 pigeons, I can say option A will guarantee. Option A is guaranteed. Okay, now tell me about option B. Some hole has at most 3 pigeons. Some hole has at most 3 pigeons. How to stop option B? A simple question I'm asking. How to stop option B? How to stop option B from happening? How to stop option B? How to prevent option B? Just tell me how to prevent option B. What you will do if you want to prevent option B? So if you want to prevent option B, see, option B is saying that there is someone with maximum 3 pigeons. Option B is saying there is some hole with maximum 3 pigeons. At least one hole with maximum 3 pigeons. So if you want to stop option B, then what you need to do? How to stop option B? So if you want to stop option B, then what you need to do? Every hole should have more than 3, right? Yes or no? Every hole should have more than 3. Every hole should have more than 3. So remember, if you want to prevent option B, what you need to do? Please tell me. To prevent option B, every hole must have more than 3 pigeons. More than 3 pigeons. Or I can say more than 3 pigeons means greater than equal to 4 pigeons. Do we have these many pigeons? Do we have these many pigeons? If you want to prevent option B, then every hole should have at least 4 pigeons. Every hole should have at least 4 pigeons. Do we have these many? We don't even have these many pigeons. We don't have these many pigeons. So what I can say? We don't have these many pigeons. Okay, how many pigeons we need if you want to stop option B? How many pigeons? At least how many pigeons you need to stop option B? To stop option B, how many pigeons we need? At least 16, right? To prevent option B, at least 16 pigeons needed. At least 16 pigeons needed. Okay, is this clear? At least 16 pigeons that are needed. But how many we have? But we have only 14. So we cannot stop option B. Yes or no? Agree with me? With 14 pigeons, can't prevent option B. Can't prevent option B. So option B is true. So B is also true. But B has nothing to do with the pigeonhole principle, right? Agree with me? B is also true, but B has nothing to do with the pigeonhole principle. Agree or not? See, pigeonhole principle does not say anything about at most. See, pigeonhole principle says at least. This pigeonhole principle, it says at least. It will say at least these many. Some hole has these many. Okay, so pigeonhole principle says that at least these many in some hole. This is what pigeonhole principle says. Agree with me? Pigeonhole principle says that at least these many in some hole. But pigeonhole principle does not say anything about at most. But logically, you can solve this question. So this option is also guaranteed. Please tell me, now are you getting my point that logical thinking is needed? In pigeonhole principle questions, logical thinking is needed. Okay? You cannot apply the formula in many cases. For example, in this question, option B, you cannot apply the formula. You cannot apply the formula. In option A, you can apply the formula. In option A, you can apply the formula 14 divided by 4 seal, that is equal to 4. Okay, but you can see in the option B, you cannot even apply the formula. So logically, you can do it. Please tell me, everyone, did you understand option B? Please tell me, did you understand option B? Option B is interesting. Did you understand option B? Okay, so very simple. Now let's move on. Tell me the answer for this question. Again, you have 14 pigeons and you have 4 pigeonholes. Can I say at least 4? At least 4 will go to same hole? Yes. Some hole has at most 3 pigeons. This is also correct. Okay, this we have already seen. This we have already seen. This we have already seen. If option B is true, then automatically option C will be true. Agree? If option B is true, then automatically option C will be true. Automatically option D will be true. Okay, because option, we have already seen option B is true. See, this we have already seen. This we have already seen. Now I am saying that if option B is true, means they at most 3 pigeons. So definitely this hole has at most 4 pigeons. This hole has at most 10 pigeons. This hole has at most 100 pigeons. So if option B is true, then automatically option C will be true. Automatically option D will be true. Okay. So these are some questions, some variations I wanted to take. Okay. Is this clear? Tell me the answer for this question. Again, you have 14 pigeons and 4 pigeonholes. Now tell me the answer for this. At least 4 pigeons in the same hole? Yes, correct. Some hole has at most 2 pigeons, can I say? This, see, this we have already seen. This option C we have already seen. This option C we have seen. But I am asking option B. We have seen. What about option B? Can you say that some hole has at most 2 pigeons? This you cannot say. This you can prevent, right? Can you prevent option B? Just prevent option B. Okay, let's do it. No problem, no problem. Let's do it. Option B is saying some hole has at most 2 pigeons. So can I do this? To prevent option B, can I put everything in the, like all the 14, can I put here? If I do this, can I stop option B? If I do this, can I prevent option B? If I do this, can I prevent option B? No, this is not preventing option B. This is not preventing option B because some hole, you can notice this hole has at most 2 pigeons. This hole has at most 2 pigeons. Okay, this hole has at most 2 pigeons. So this is not preventing option B. Please understand. So this is not preventing option B. This is not preventing option B. So how to prevent option B? Then tell me. See, option B is saying some hole has at most 2 people. At most 2 people in, there is some room. It's like in a hotel. Think about a hotel. Think about it. In some hotel, you are saying there is some room with at most 2 people. There is some room. There is at least one room in this hotel with at most 2 people. If you want to prove it wrong, what you will need to do? You are the hotel manager. The police is coming to you and police is saying that there is at least one room. Some room has at most 2 people. If you want to prove them wrong, what you will need to do? Every room should have more than 2 people, right? Agree? Okay, so if you want to prevent option B, then every room should have, then in this situation, every room, every pigeonhole must have more than 2 people, or I can say greater than equal to 2, greater than equal to 3 pigeons. Simple. And this I can do. This is doable. This is possible. Yes, this is possible. This is very much possible. What you can do? You can do it. This is very much possible. So what I can do? I can just do like this. I can put 3 here, 3 here, 3 here. Okay. Total 14 I have. Remember, total 14 I have. So what I can do? 4 here, 4 here. Very simple. Yes or no? You can see I prevented option B. You can easily notice I have prevented option B. Is this point clear? Or you can do like this, or no problem. This is also fine. Or what you can do? You can do like this, 3, 3, 3, and 5 here. That is also correct. This also fine. This is also fine. But the point is option B is not always true. Can I say option B is not guaranteed? You cannot guarantee option B. There is no guarantee for option B. Now, are you understanding the pigeonhole principle? Are you feeling more confident? I am taking variety of questions. See, variations I am taking. At most, at least, exactly, all the variations I am taking. Okay. So let me tell you actually, if you read the pigeonhole principle in any book, then only one result you will see. If you study this pigeonhole principle, if you study in any book, in any standard book, if you study, then only one result you will find. In any standard book, pigeonhole principle, if you study in any standard book, only one result you will find. What is that? That is this, that you have n objects and k boxes. Then what will happen? Then some box will have how many? Then some box has seal n divided by k objects. This is what I'm saying. Remember, some box has at least these many. Some box has at least these many objects. Okay, so this is the point. Some box has at least these many. So this you will find whatever book you study. Is this point clear? Whatever book you study, these many, this result you will find in any book. But I found this result in the Stanford University slides. This slide is taken from Stanford University. Okay, this is taken from Stanford University. Okay, what this slide is saying? The first result you already know, right? Agree? The first result you already know. Agree or not? See, if you want to distribute, you are distributing m objects to n boxes. Then some box will have at least seal m divided by m objects in it. This we have already seen. And if you notice, we have also seen the second one. Have we seen the second one? With examples we have seen. Agree? Agree with me that some box will have at most these many. With examples we have seen the second one. The second result we have seen with examples. Okay. With examples we have seen the second result. So let me tell you. Let's see the second result. Let's do some more questions on the second result. Let's assume you have total 50 objects. And let's assume you have, let me assume that you have total 7 boxes. Okay, 50 objects, 7 boxes. Now, what is the first result? What is the first result saying? The first result is saying, tell me, some box will have how many? Some box will have how many? Some box has at least 50 divided by 7 seal. That value is what? That value is 8. Some box has 8. This is the first result, right? Agree? This is the first result. This we already have seen. Okay, you can just prove it easily. Okay, just prove it. How to prove it? Without formula, how can you prove it? Without formula, how to prove it? Very simple. Just do the uniform distribution. If you uniformly distribute, then what will happen? If you do the uniform distribution, then what will happen? See, 50 objects, 7 boxes. If you do the uniform distribution, then 7 point something, this value will come. So if I put 7 in every box, there are total 7 boxes. There are total 7 boxes, B1, B2, B3 and B7. If I put everywhere 7, 7, 7, if I put 7, 7, 7, if I put 7, 7, 7, 7, still something is remaining. Still what will happen? One object remaining. One object remaining. Okay. If you put this object also, then what will happen? One object is remaining. One object is remaining. If you put this object also, then what will happen? If you put this object also, then some box will contain at least 8 objects. So very simple. Some box will contain at least 8 objects. So this is what you are going to get. You will get this. You will get this, that some box will contain at least these many objects. So you will get it. Simple. Now tell me. Now something interesting. What is that? The second result, let's see. Without formula, can you do? The second result without formula. Okay. Can I say you have total? See, let's prove the second result. Now what we are going to do? The second result is actually saying that some box will have at most. Now instead of this seal, take the floor. This is the second result. Second result is saying that some box has at most floor. That means 7 objects. Just prove it. Can you prove it? See, in the GATE exam, if this question will come, some option will come. In the option, this will be given. This will be given in the option. Some box has at most 7 objects. Some box has at most 7 objects. Can you prove it? Your task is to prove it. This is your task. Can you prove it? So let's stop this from happening. Can you stop this from happening? Can we stop? Can we prevent? Can we prevent some box to have at most 7 objects? Can we prevent some box? Or I can say, it's like, let me say this is your second result. Let me call it statement T. Let's call it statement T. Okay. Or maybe whatever, like for example, let's call it statement P. For a moment, let me call it statement P. Now tell me, can you prevent of statement P? Can you prevent statement P? So if I want to prevent statement P, what I need to do? To prevent statement P, what I need to do? To prevent, I want to make statement P false. To prevent statement P, what I need to do? See, statement P is saying that there is some box, at least one box with at most 7 objects. Some box with at most 7 objects. There is some room in this hotel with at most 7 people. At least one room is there in this hotel. There is at least one room with at most 7 people. So if you want to prevent it, then what you need to do? Then what you will do? Then every box will, you need to put what? Then every box should have, I can say, more than 7. Yes or no? More than 7 objects. Agree? Agree with me? If you want to prevent, this is what you need to do. To prevent. Okay. Or I can simply say that greater than equal to 8. Now, can you do this? If you do this, how many objects you need? If you do this, how many objects you need? Every box is having greater than equal to 8 objects. If you do this, then minimum how many objects you need? 8 multiplied by 7. Okay, we need 8 because there are total 8 boxes. Because there are total, 7 boxes. Sorry. There are total 7 boxes. So what we need? We need 7 boxes multiplied by 8. We need minimum these many. We need minimum 7 multiplied by 8. That is what? That is 63. 56. That is 56. So you can see we need minimum these many objects. Do we have these many objects? Do we have these many objects? Please tell me. We need these many objects. Minimum these many. Minimum. We need these many objects. But we don't have. But we have only 50. But we have only 50 objects. Okay, so that is the reason I can say statement P will be true. So statement P will be true. So what is statement P? So remember, this statement P will be true. Did you understand? Please tell me. Did you understand both the results? Did you understand both the results? Some box has at most n by here you take the floor n by, or I can say 50 divided by 7. 50 divided by 7, that is equal to 7 objects. Okay, so very simple. So there are two results. These are the two results. One thing I want to tell you, that this I found in a Stanford University slide. This is not easy to find. Whatever book you study, you can study Kenneth Rosen, Grimaldi, whatever book you study, you check it out. Today you can, on the Google, you put pigeonhole principle. If you study almost, I can say 5 to 10 books, if you study, you will not find the second result. This second result you will not find. That is the reason I have taken examples also before telling you this result. See, I told you this result later. Before telling you this result, I have taken questions. Yesterday also we have taken one question, this type of question. Do you remember? This type of question we have taken yesterday also. So that is the reason I am saying, before telling you this result, I have already taken almost 5 to 6 questions I have already taken, so that you feel comfortable with this result. And another example, another question we have taken here also. So please tell me, did you understand? So these two results, did you understand? Let me know. So finally, this is the conclusion. Will you apply the formula? Will you apply the formula in the exam? Will you apply the formula? Don't apply the formula, just apply the logic. There is no need to apply the formula. There are some questions you cannot solve using formula. I told you, I have already given to you. Some questions I have given to you, which you cannot solve using the formula. Okay, so that is the reason I am saying, don't apply the formula, just apply the logical thinking, but you can remember this conclusion. Okay, maybe some question can come, maybe MSQ question can come, direct statement is given to you. So you can just final this conclusion, you can remember. What is the conclusion? That if you have total n objects and total k boxes, okay, you want to distribute, okay, n objects, k boxes, this distribution you do, then in this situation there are two results. What are those? The first result is some box has at least how many? Some box has at least how many? At least n divided by k seal objects. Okay, so this is the one result. This is the first result. Some box has at least these many objects. And another result is what? Another result is some box has at most n divided by k floor objects. With examples, we have seen how to prove it. Okay. With multiple examples, we have seen how to prove this, Okay. I hope this point is clear. So there are two results. These are the two results. Is this clear? Let me know. Simple. So now let's move on. So generalized pigeonhole principle we have seen. So these are the final things. These are the tools that we are using for solving questions. Note number 1, if the question is asking for guarantee, then what you will do? Question is asking for guarantee of event X. What you will do? You will try to prevent event X. This is what you will do. And the second point, the best way to prevent too much in a single room. What is the best way? That is uniform distribution. Do the uniform distribution. And the third point, don't forget to use your common sense. Common sense is very important. So don't forget to use it. Use your common sense, use your intuition, use your logical thinking. I can also say, use your logical thinking. That will help you. Okay, let's move on now. So this question we have already seen. The grades question. 5 grades. This question we have seen. Tell me the answer for this quickly. Tell me the answer. Some practice. Let's do some practice. You have this set 1 to 8. N integers will be chosen. You are choosing n distinct integers are chosen from set A. How big How big n have to be to guarantee, you want to ensure, you want to guarantee that sum of two of chosen integers is 9. Tell me the answer. This question we have done yesterday, if you remember. This question we have done yesterday. Okay. So if you remember, I told you, you can watch the last lecture. Yesterday we have seen this question. The set is 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the set that is given to you. The question is saying that how big you are choosing, some numbers you are choosing. Okay, remember? And distinct integers are chosen from A. From A. So from this A, you are choosing, remember, a subset you are choosing. A subset you are choosing, let's call it P. This subset you are choosing. And the question is asking that you have to guarantee that sum of two chosen numbers is 9. So you have to guarantee that there exists A comma B. There exists A comma B where A comma B are different. There exists A comma B where A comma B are different, because the question is already using the word distinct. See, the question is already using the word distinct. Focus here. The question is already using the word distinct. So because of this word, you cannot consider here actually already 9 you cannot get. Two equal numbers you cannot give you 9. But anyway, this question is saying that there exists A comma B where A is not equal to B, such that A plus B should be equal to 9. This is what you want. Okay, so just find out who are capable of giving you 9. Just find out. Okay, because this is what you want, right? This is what you want. You want A plus B equal to 9. You want two different numbers giving you A plus B equal to 9. So just find out who are capable to give you 9. Tell me who are capable to give you 9. You want A plus B equal to 9. This is what you want. Who are capable of becoming these A comma B? Who is capable of becoming A comma B? See, I can say 1 comma 8 is capable, right? Next, I can say 2 comma 7 is capable. Next, you can notice 3 comma 4 is capable. This is capable. 3 comma 4 is capable. Similarly, what about, 3, not 3 comma 4, 3 comma 5. 3 comma 5 is capable. 4 comma summation should be equal to 9. Summation should be equal to 9. Sorry. 3 comma 6 is capable. 4 comma 5 are capable. These are the capable people. Okay. So these people can give you summation 9. This can give you summation 9. This can give you, this can give you, this can give you. They can give you summation 9. Okay. Now you tell me. First you will prevent, then you will add 1. Right? This is what you will do. Agree with me? What you will do? First you prevent. First you do your best to prevent. So first you prevent, do your best. Okay, try to prevent whatever, I can say, do your best to prevent. So, or I can say just prevent with maximum. What is the maximum prevention you can do? You prevent, but you take maximum people. So tell me what you can do. You can take 1 from here. You can take 2 from here. Can you take 3,6? Can you take 3,6? Can you take 3,6? If I take 3,6, then I will get summation equal to 9. I will get summation equal to 9, but I want to prevent. So I can take 6 from here. I can take 5 from here. So far, I did not get the summation, right? Here, there is no guarantee of summation. So far, I did not get summation 9. Okay, there is no summation 9. So far, prevented. So far, we have prevented summation 9. Prevented summation equal to 9. But if I add one more number, then what will happen? If I add one more number, now there is a guarantee. For sure, you will get summation equal to 9. Means A plus B, there will be two numbers who will give you summation equal to 9. So the answer will be what? How big n should be there to guarantee you will get a summation 9? How big? The question is asking how big. How big? So I can say this n should be at least bigger than 5. Okay. This n should be greater than equal to 5. This n should be greater than equal to 5. Because remember, if I choose 4 people here, can I guarantee from this, if I choose 4 people, 4 numbers I choose, can I guarantee I will get summation 9? There is no guarantee, because what I can do, I can choose 1, 2, 3, 4. These I can choose. I'm not getting summation equal to 9. So with 4 people, I cannot guarantee, I cannot ensure with 4 people, but I can ensure with 5 people. At least 5 people you must choose. At least 5 people you must choose to guarantee, to ensure a plus b equal to 9. Simple. At least 5 numbers. Very simple. So this is your question. Now let's move on. Tell me the answer for this one. This is your set from 1 to 100. N numbers you are choosing. You are choosing n. How big this n should be to make sure that summation is equal to 101. To make sure you get summation equal to 101. So the same question, the same previous question, what you can do? Just find who are capable to give you 101. Tell me, who are capable to give you 101? Tell me. Because ultimately we want 101. Sum of 2 chosen is 101. What we want? We want a plus b equal to 101. Remember, this is what we want. Summation should be equal to 101. This is what we want. 2 numbers. Okay, so just see which 2 numbers are capable to give you 101. So you can notice the set. The set is 1 to 100. This is the set. So I can say 1, 100, 2, 99. Like this, if you do, like this, if I do, at some point of time, I will come where? At some point of time, I will go to 49. With 49, what I need to take? With 49, I need to take what? I think 52, right? Yes or no? Okay. With 50, what should I take? With 50, I should take 51. That's it. Now you can stop. Okay, should I continue? See, if I continue, then I've already considered. This pair I've already considered. So you don't have to consider it. This pair is already considered. So this is what you can do. Only these things, they are capable to give you 101. Now what you can do? First, what you can do, you can prevent. Okay, first you prevent. Do the maximum prevention. Okay, do the just prevent, the worst case prevention. Okay, maximum prevent. So tell me, or I can say worst case. What the worst case prevention you can do? In worst case, what you can do? You can take one number from here, one number from here, from everywhere you can take one number. Like I can take 1 to 50. I can take these. Okay, I can take these. So at this point of time, there is no guarantee. See, if I select 50 people, okay, from this set, if I choose 50 numbers, then there is no guarantee. There is no guarantee of getting 101, right? Yes or no? There is no guarantee of getting 101. There is no guarantee of getting 101. But what I can do? If I add one more, now there is guarantee. If I add one more, now there is a guarantee. Definitely, for sure, you will get a plus b equal to 101. Okay, so here there is no not sure. But if I add one more, it is sure. So answer will be what? Answer will be 51. So for this question, answer will be what? Answer will be this n must be greater than equal to 51. Okay, this n must be greater than equal to 51. From this, you select at least 51 numbers. From this, you select at least 51 numbers to ensure a plus b equal to 101. Okay, let's move on now. This is your GATE 2000 question. Tell me the answer. This is your GATE Computer Science 2000 question on pigeonhole principle. The question is saying that minimum number of cards to be dealt from an arbitrary 52 cards to guarantee. We want to guarantee that 3 cards are from the same suit. 3 cards are from the same suit. Okay, so you know these are the suits. You already know these are the suits. There are 4 suits: club, heart, spade, diamond. These are the 4 suits. And what you want? You want to guarantee that 3 cards of the same suit are there. Okay, so remember, this event you want to guarantee. Which event? Let me call it event X. Which event X you want to guarantee? See, this event X you want to guarantee. Which event? You want at least 3 cards of the same suit. At least 3 cards of same suit. This is what you want. Okay, you want that 3 cards of same suit. You want this. Okay, so this is what you want. Now you tell me how to prevent it. If I want to prevent this event from happening, how to prevent event X? How to prevent event X? I want to prevent event X. How to prevent event X? Event X, if you want to prevent, then what you need to do? For every suit, you will take maximum 2 cards, right? Yes or no? Maximum 2 cards you will choose from every suit. From every suit, you can choose maximum 2 cards if you want to prevent X. So if I want to prevent X, this is what you can do. To prevent this event, what you can do, from every suit, you can take 2 cards. These are the suits. Like for example, spade, club, diamond, and your heart. Okay, so these are the suits. These are the 4 suits. Now you can notice. Remember, the question is saying guarantee. This guarantee I want. I want this guarantee. I want the guarantee of event X. Event X means at least 3 cards of the same suit. This I want to guarantee. So what you can do? Can you prevent this? If you want to prevent this, then to prevent this from happening, you don't want this to happen, then what you need? At most 2 cards of every suit. This is what you can do. This you can do if you want to stop this from happening. So what you can do? From everywhere you can take at most 2, at most 2, at most 2, at most 2. So can you notice that maximum how many cards I can draw such that I can prevent event X? Can you notice? Maximum 8 cards can be drawn. Maximum 8 cards can be drawn. Maximum 8 cards can be drawn for a possibility to prevent X. Yes or no? Maximum 8 cards can be drawn for a possibility to prevent X. For a possibility to prevent X. Is this clear? Simple? Okay, right? So maximum 8 cards I can draw for a possibility to prevent X. So if I add one more card, if I draw one more card, now there is no possibility to prevent X, right? Now there is no possibility to prevent X. Now there is no possibility to prevent X. So it simply means now there is a guarantee that event X will happen. Okay, if I add one more, if I draw one more card, then now there is a guarantee that event X will happen. Okay, now there is a guarantee that at least 3 cards of same suit. This will definitely happen. So very simple answer will be, the question is asking minimum. Because the question is asking minimum, so the answer will be 9. Yes or no? If the question is not asking for minimum, let me remove the minimum. Now tell me the answer. Let me remove the minimum. I am saying the number of cards to guarantee 3 cards of same suit. So now the answer will be, this also will give you guarantee, this also will give you guarantee. Is this point clear? 9 will also give you guarantee and 12 will also give you guarantee. Basically, every number greater than equal to 9 will be the answer. Okay, every number greater than equal to 9 will be the answer. But the question is asking for minimum. Because the question is asking for minimum, so the answer will be, because of this word, the answer will be 9. I hope this point is clear. So this is your GATE 2000 question. Now let's solve this TIFR Computer Science 2014 question. So try this question. TIFR Computer Science 2014 question. So let's see. The rules for a University of Bombay. So the rules for University of Bombay Just give me a second. Okay, yes. So let's start. TIFR Computer Science 2014 question. The rules for the University of Bombay 5-a-side cricket competition. Okay. Specify that members of each team must have birthdays in same month. What is the minimum number of mathematics students needed to be enrolled in the department to guarantee that they can create a team? To guarantee that they can create a team, there is a possibility to create a team. Did you understand the question? See, the question is very simple. We are saying that in this, there is a university. In this university, what you want? There is a department. There is a cricket tournament. Okay, there is a cricket tournament. So there is some cricket tournament is happening in this university. And in this cricket tournament, 5 people in one side, basically 5 people team. It's like I can say 5 people each team. In every team, there will be total 5 people. So this cricket tournament is happening. And the question is saying that there is a condition. What is the condition? For every department, there is a condition. Whatever computer science department, math department, in every department, there is a condition. What is that? This department will create a 5-member team. This department will create a 5-member team. Okay, so this is also creating 5-member team. Right? This is also creating 5-member team. This is also creating 5-member team, and so on. Now you tell me, but what is the condition? What is the condition? The condition is that all these 5 members of each team must have birthdays in the same month. So means this mathematics department, 5 members, this is creating 5 members team. And this is the condition that all these 5 members should have birthday in the same month. Must have birthday in the same month. Must have birthday in the same month. Okay, is this clear? So now we want to guarantee that this type of team we can create. Remember, we want to guarantee that this type of team we can create. What we want? Remember, this word is very important. We want to guarantee that this type of team we can create. Now you are in the mathematics department. What is going on in the mathematics department? They want to guarantee that this type of team they can create. Okay. Now tell me, if they enroll only 5 people, can they guarantee, like, let's assume they enroll 5 people. Can they guarantee that these 5 people will have birthday in the same month? Tell me. In this math department, if you enroll 5 people, if you enroll 5 members, or I can say 5 students, then is there any guarantee that these 5 students will have birthday in the same month? There is no guarantee, right? Yes or no? There is no guarantee that they will have birthday in the same month. No guarantee of having birthday in same month. So very simple. There is no guarantee of having birthday in the same month. Okay. So what they need to do, what these people they need to do. So this mathematics department, they are thinking like this. So how many months are there? There are total 12 months, right? So there are total January, February, December. There are total 12 months. So they know that this point they know. In worst case, how many students they need to enroll? In worst case, what can happen? See, in worst case, you tell me what can happen. In worst case, what can happen? In worst case, this can happen that 5 they enroll, and 4 people from this month, 4 people from this month, 4 people from this month come. Is this point clear? See, in worst case, what can happen? In worst case, what can happen? That when they enroll, then 4 people of January month are coming, 4 people of February month, and so on, 4 people of December months are coming. So this can happen. Now can they create a team? No. So you can notice with 48 people, they cannot create a team. But if they enroll one more student, if they enroll one more student, now they can definitely create a team. Is this point clear? If they enroll one more student, with 48 students, there is no guarantee. There is no guarantee with 48 students. There is no guarantee. But if they enroll one more student, then definitely there is a guarantee they can create a team. So with 49 students, they can create a team. Is this point clear? So what the question is asking for minimum number of students. So that will be 49. 49 students they need to enroll. I hope this point is clear. And if I remove this minimum word, now what will be the answer? If I remove this minimum word, now what will be the answer? What is the number of mathematics student to guarantee? Now the answer will be any number greater than equal to 49. Okay, any number greater than equal to 49 will guarantee. Okay, so this is your pigeonhole principle. I hope you understood. So very, very simple. I hope all these points are clear. Let's see this question. TIFR Computer Science 2018 question. What is the minimum number of students needed in a class, again to guarantee? We won't guarantee that there are at least 6 students whose birthday in the same month. We want to guarantee this. Okay, we want to guarantee that there are at least 6 students whose birthday is in the same month. So the answer is very simple. In the worst case, what can happen? Just tell me. In worst case, what can happen? January, February, December. In worst case, this can happen. Just think about the worst case. In worst case, what can happen? See, in worst case, this can happen that you want 6 people. Remember, you want at least 6 students in the same month. You want at least 6 students in the same month. So in the worst case, what can happen? 5 students have January birthday month. 5 students have birthday in the February. 5 students have birthday in the December. So in the worst case, what can happen? It's like I can say 60 students if you have. Is there any guarantee with the 60 students? Do we have any guarantee with the 60 students? Remember what we want? We want at least 6 in the same month. At least 6 students must have birthday in the same month. So you can notice with 60 students, there is no guarantee. But if I add one more student, with 60 students, there is no guarantee. Still, there is no guarantee. But if I add one more student, now there is a guarantee. Okay, now with 61, I can say, definitely, I can say at least 6 students have birthday in same month. Have same month birthday. Okay, so the answer will be 61. Answer will be option C. Okay, very simple. And in the same question, because the question is asking for minimum, so the answer will be 61. But in the same question, if I remove the minimum word, now I'm asking the number of students to guarantee. Okay, the number of students to guarantee. So any number greater than equal to 61 will guarantee. Remember, any number greater than equal to 61. Okay, if you have greater than equal to 61, if you have these many students, then definitely at least 6 students will have birthday in the same month. So any number greater than equal to 61 will work. These options will work if you remove the minimum word. Because of this minimum word, answer will be 61. Okay, so we have seen these questions also. Now this is the last question that is remaining, and we will solve it tomorrow. So you can try this. Let me tell you, in the GATE exam, also in the TIFR exam, all the pigeonhole principles we have, principal questions we have taken. Is this point clear? From the pigeonhole principle, all the GATE exam question, all the TIFR exam questions we have taken. All the standard variations we have done. Okay, this is the last question that is remaining. You try this question yourself. Today you try, tomorrow we will solve it. Okay, so tomorrow I am going to solve this question also. The same question you can find in the Kenneth Rosen book. The same question you can also find in the Kenneth Rosen book. So we will solve this question also. Let me tell you one more thing. I will tell you one more interesting problem. One last interesting problem I will tell you. So some Kenneth Rosen questions we will solve tomorrow. This question we will solve. This question we will solve. Okay. And yeah, so this cool result I am going to tell you tomorrow. this final, this is the last cool result. So these questions I will give you. Remember, I will upload this question in the annotated notes. So you can try this question. This is Kenneth Rosen, question number 6. You can try this question. You can try this question also. Okay. You can try this. You can try this variation also. You can try this variation also. This variation also you can try. You can try this question also. And you can try this question also. See, in this GATE exam question, there is and here. So you try this, think about it, spend some time, just do it. Okay. Don't see the solution. Try this, spend maybe 5 to 10 minutes or maybe 20 minutes. Don't see the solution. Try this. In this, there is and here. There is and, right? Now there is one more variation I can create. For example, this variation I can create, I can put or. So try all these questions. And the final thing, this we will discuss tomorrow. This is a very cool result. Okay. Actually, why I want to discuss this result, let me tell you. What is the reason I want to discuss this? Because in most of the books, you will find this result. It's like whenever any standard book of I can say pigeonhole principle, you will find this question. Okay. So this is, I can say, maybe someday this question can come in the GATE exam. This question has not come in the GATE exam, but this result is so popular. I can say this is so popular that I'm thinking that maybe someday it will come in the GATE exam. So I will discuss this also. Okay. And once we discuss this, then let me tell you, pigeonhole principle will be over. In pigeonhole principle, all the GATE exam question, all the TIFR exam question, all the standard questions, all the GATE relevant Kenneth Rosen questions, everything we have taken. Okay. So the complete package, the complete pigeonhole principle we have seen. Okay. So tomorrow we will finish it. Only some questions are remaining. As you can see, some 4 or 5 questions I am giving you as homework. We will discuss these questions tomorrow, and this final result we will discuss tomorrow. Okay. So that's it. This is your pigeonhole principle. Some questions that we have seen, these questions you will not find in standard books. Okay. Some questions I have taken from Stanford University lectures. Okay. So that is the reason I am telling you that this is a complete package of pigeonhole principle. Okay. So are you confident in the pigeonhole principle? Did you understand? Are you confident? Whatever question comes, can you solve that question logically? With logical thinking, can you solve that question? Okay. So thank you, everyone. See you tomorrow. Okay. If anyone has any doubt, you can ask. Shivam is asking for some doubt. Yes. Shivam, please tell me what is the doubt. Anyone has any doubt, you can ask. Yes. Divanshu, what is the doubt? Please tell me. You can raise your hand if you have any technical doubt. Please tell me. In this session, pigeonhole principle, in the pigeonhole principle, do you have any doubt? Shivam, non-technical doubt, you can ask me in the Telegram group, in the private Telegram group. You can tag me. I will reply. I reply to all the messages in which I am tagged. By mistake, if I missed some message, you can tag me again. Okay. So on the Go Classes private Telegram group, you send me your non-technical doubt. I will answer it. We can also have some conversation on the call. Shivam, you can also call me. We can schedule a call and then you can call me. Divanshu, what is your doubt? Please tell me. You can raise your hand and you can ask. Please tell me. Please raise your hand. You can speak and you can ask. Hello, Divanshu, what is the doubt? Please tell me what is your doubt. Can you send me the message? Tell me what is your doubt. Anyone has any other doubt? in pigeonhole principle, in the yesterday's lecture, in the last lecture, in this lecture, anyone has any other doubt? Any doubt in any question, in any theorem, any result, anything? Please tell me. Do you have any doubt in the pigeonhole principle? All the questions that we have seen, every theorem that we have seen, everything. So Divyanshu is asking, sir, in today's question we have discussed that if there are 16 pigeons, then we can put 4 in each. What if we put all 16 in one? No. See, I told you that at least these many we need for a possibility. See, Divyanshu, these will give me a possibility. See what I'm saying. Remember, if you have 14 pigeons, and let's assume there are 4 pigeonholes. Now you can notice that 14 pigeons, 4 pigeonholes. If I want to put, for example, consider this statement that some hole has at most 3 pigeons. This was the question, right? Agree? This was the question, that some hole has at most 3 pigeons. Now I am telling you, this is not even I am telling you that you cannot prevent it. See what I'm saying. I am saying this is true. This statement is true because if you want to prevent it, there is no possibility. See, if you want to prevent, what you need to do? If you want to prevent, what we need to do? If you want to prevent, then every hole must have what? If you want to prevent this, then every hole should have more than 4 pigeons, correct? Yes or no? So you can see, if you want to prevent this, then every hole should have more than 1 pigeons. But there is no possibility. I am telling you that there is no possibility of prevention. This is not possible. Please understand. Please understand this. This is not possible. Is this clear? Okay, because we have only 14 pigeons. So every hole should have greater than equal to 4 pigeons. So we need at least 16 pigeons for a possibility. First of all, with 14 pigeons, this is not even possible. Please understand. This is not possible. There is no possibility. There is no possibility. This is not possible. And because this is not possible, prevention is not possible, right? Prevention is not possible, right? Agree? I can say not possible. That simply means prevention not possible. Prevention of this statement not possible. This statement prevention not possible. So prevention not possible. If this statement I cannot make it false, then what it means? This statement I cannot make it false. I cannot prevent it. This means this is true. So this statement is true. But you can notice, if I give you 16 pigeons, now, if I give you 16 pigeons, now tell me. Now tell me, what about this statement? Now can you guarantee that this will happen? Some hole has at most 3 pigeons. Now can you prevent this? Now can we prevent? Just try this. Can we prevent? So if you want to prevent, what you need? Again, what you need if you want to prevent? To prevent. Remember, I am saying that to prevent. So if you want to prevent, then every hole will have more than equal to 4. Every hole will have more than equal to 4, more than equal to 4, more than equal to 4. Yes, I can prevent. Agree with me? I can put 4 here. I can put 4 here. So prevention is possible. What I can do, I can put 4 here. 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 Because I have 16 pigeons. So I can put 4, 4, 4, 4. So you can see prevention is possible. This statement, I can simply say this statement is wrong. Why this statement is false? This statement is false because I can prevent this statement. Is this clear? So I can say that this statement is false because prevention possible. Because prevention possible. Is this point clear? Is your doubt clear, Divyanshu? So remember, with 16 pigeons, there is no guarantee. With 16 pigeons, there is no guarantee. There is no guarantee. Actually, with 16 pigeons, this statement becomes false. With 14 pigeons, this statement becomes true. This same statement, this is true when you have 14 pigeons, and this statement, this same statement is false when you have 16 pigeons. Because when you have 16 pigeons, we can make it false. We can prevent it. When you have 14 pigeons, we cannot prevent it. Is your doubt clear, Divyanshu? Was this your doubt? So I'm just telling you, if you want prevention possible, then at least 16 pigeons you need. This is what I was saying. I was saying that if you want to make it false, then at least 16 pigeons you need. Okay, is this point clear? If you want to make this statement false, then at least 16 pigeons you need. Any other doubt? We can say that, yeah, see, you can see Mukund is saying that we can say that with less than 16 pigeons, our statement will definitely true. Yes, very good, Mukund, very good. If you have less than 16 pigeons, see, this statement, focus on this statement. Okay, this statement. If you have less than 16 pigeons, then this statement will definitely be true. This will definitely be true. Okay. But if you have more than greater than equal to 16 pigeons, then this statement, you can see, if you have, for example, if you have 16 pigeons, now for 16 pigeons, this statement is false. In case of 16 pigeons, this statement is false. Okay. You may or may not do this. Is this clear, Divyanshu? Any doubt? Any other doubt? Mukund, Divyanshu. Clear, or should I explain? Any doubt? Please tell me. झूठ मत बोलना. If there is any doubt, just let me know. Okay. So I think everything is clear. So tomorrow we will solve the remaining questions. I will give you these 4 or 5 questions. I will give you as a homework in the annotated notes. You try these questions. Tomorrow we will discuss. Okay. Thank you, everyone. Thank you.